The mystery before the Big Bang, the theory that could change everything. Hello, welcome to my laboratory. Today, we're going to explore one of the most intriguing questions in modern cosmology. What really happened before the Big Bang? You've probably heard the idea that everything began with an extremely rapid expansion. But over the past few years, many researchers have started to wonder if that story might be even deeper than we thought. One surprising hypothesis suggests that our universe may have formed inside a supermassive black hole. It sounds unlikely, maybe even strange, but when we look closely, the idea makes more sense than you'd expect. So today, I want to walk you through this proposal with calm, clarity, and logic. First, we need to understand what the Big Bang actually represents. Contrary to what many people imagine, it wasn't a regular explosion. It was the moment when space itself began expanding, carrying with it all the matter and energy that would eventually become galaxies, stars, planets, and even time. For decades, scientists believed this moment marked the absolute beginning of the universe. But this view depends on something that has always made physicists uneasy, the so-called singularity, a point of infinite density where the laws of physics simply break down. Anytime the math gives us a literal infinity, it usually means we're missing an important part of the puzzle. That discomfort pushed many researchers to look for alternatives, and from that search emerged a new way to think about the origin of the cosmos. This recent hypothesis proposes that our universe might have been born inside a black hole from another universe. Picture an extremely massive region collapsing under its own gravity. This collapse forms a black hole. As matter falls inward, it becomes more and more compressed. But quantum physics tells us there's a limit to how much it can be squeezed. And once that limit is reached, something extraordinary can happen, a gravitational bounce. To visualize it, imagine the universe as a giant spring. At first, it's pressed down, getting smaller and denser, but eventually you can't compress it any further. Then suddenly, the spring snaps back. That rebound is the gravitational bounce, and it could be exactly what triggered the rapid expansion we call the Big Bang. In other words, the Big Bang might not have been the beginning of everything, but a transition inside a much larger process. And why does this idea make sense? First, it avoids the problem of an infinite point. In the traditional model, the universe starts from something impossibly small and infinitely dense, something physics can't really describe. In this new model, the universe reaches an extreme limit, but one that remains physically possible. It starts from a maximum, not from the impossible. Second, this proposal naturally explains the initial push of the Big Bang. In the classic model, the universe needs a phase called cosmic inflation, an absurdly fast expansion that seems to appear out of nowhere. In the rebound model, this push doesn't need to be added artificially. It's a natural consequence of maximum compression, followed by a bounce. Third, this hypothesis brings together two ideas that, in the traditional model, are completely separate: the rapid acceleration at the beginning and the slower acceleration we observe today. Instead of two independent phenomena, both could arise from the same underlying mechanism, acting differently across cosmic history, a simpler and more elegant solution. And there's one more interesting point. This theory predicts that the universe has a tiny amount of curvature. The traditional model considers the cosmos perfectly flat, but this idea suggests something slightly different. The universe would be almost flat, but not exactly. Its curvature would be as subtle as the Earth's, imperceptible when you're standing on it, but obvious when you look from far away. Measuring this isn't easy, but space missions like Euclid were designed precisely to detect details like this. If they find the predicted curvature, it would be a strong sign that we're on the right path, not final proof, but a powerful clue. And if this theory is correct, what does it mean for us? It means our universe might be the inside of a black hole. It means every black hole could give birth to a new universe. And it means our own cosmos might be creating others right now. This transforms the way we see reality. Instead of a single universe, we might be part of a vast cosmic family tree, where each universe can create descendants. And all of this comes from the two pillars of modern physics: general relativity and quantum mechanics. It's incredible to think how deep our answers can go when we learn to ask better questions. If you enjoy exploring the universe in a simple, curious, and fun way, I invite you to subscribe to the channel. Turn on notifications to follow our next investigations, and leave a like. It really helps, especially now in the beginning. Thank you for joining me in this analysis. I'll see you in the next scientific investigation.